Hi everyone, welcome back to my YouTube channel. This is Raz, and in this video, we're going to discuss how to segregate mixed costs using the scatter graph method and the high-low method. So if you're ready, let's start. In our previous video, we have discussed already the concept of cost. And by now, you have already an idea of what is cost and how costs are classified. They could be classified according to their elements, their nature, their controllability, and a lot more others. And among other costs classification, cost may be classified into fixed costs, variable costs, or mixed costs. We have discussed already what are these costs. So as a review of our previous discussion, when we say fixed costs, these are costs that generally remain unaffected by changes in the volume of output or sales. When a cost is maintained or remains the same, even if there is an increase or decrease in the production level, then that cost is said to be fixed. Examples of these costs are the monthly depreciation of equipment and the fixed monthly rentals. Because whether the production is increased or decreased, these costs will remain the same. On the other hand, when we say variable costs, these are costs that vary in a directly proportional way to changes in the volume of output or sales. So when we say variable costs, these are costs that are dependent to the production level. They are sensitive to the production level of a company. So, examples of these costs are the cost of flour and sugar in making pastries. Why? Because as the units produced increases, the more you make pastries, the more you will spend on the flour and sugar. Okay, so hence variable costs. On the other hand, mixed costs are costs which have the characteristics of both fixed and variable costs. Examples of these costs are the taxi fare, the water bills, and commissions, and others. Okay, so our discussion in this video will focus on these three costs. Why do we need to account for fixed and variable costs? Why do we need to determine what is fixed and what is variable? So variable costs increases or decreases depending on the production level, right? But fixed costs do not change regardless of the production level in a relevant range. This means that for a variable cost, the more you produce, the more you will incur these costs. And for fixed costs, whether you produce or not, whether there is an increase or decrease in the production, the cost will remain the same because it's fixed. It is a fix for a relevant period. Okay? So that also means that they will stay the same during a relevant period or range. This also implies whether the organization is producing more or less, the fixed cost will be at the same level. And this is where managers are more interested on because fixed cost is a crucial amount that they need to recover. Let's put it this way. Variable cost, you will incur more if you will produce more. That also means that if you will not produce anything, you will not incur variable costs, right? But fixed costs are always there. It's constant. It remains the same, which means that the production cannot be stopped just because you thought of avoiding variable costs. Because when the production is stopped, then the company would still be incurring fixed costs and producing nothing. Okay? So fixed cost is something that the company should recover because that is what they constantly incur, right? So this is where the production managers need to focus on, and they need to answer how many should they produce and sell to recover fixed costs. Okay? But what about mixed costs? Mixed costs are something which has both the characteristics of a fixed and a variable costs. So mixed costs add complications actually in the accounting of costs because mixed costs are both variable and fixed, and the decision making process of the managers would be more complicated, especially when mixed costs are present in the production. So there is a need to segregate which is variable and which is fixed. Hence, we need to separate the variable and the fixed components of the mixed cost. So this is where our discussion will focus on, okay? How to segregate mixed costs, variable or fixed. So here are the techniques in segregating mixed costs. First, the scatter graph or the graphical method. The second one, the high-low method. And of course, the third one, the regression analysis. So there are only three techniques in segregating mixed costs, and we will focus in this video the scatter graph and the high-low method. Okay, so in the scatter graph or graphical method, it uses a graphical solution in separating mixed costs, and it is used to determine the relationship between two variables, the x and the y. So in this method, we're going to graph the relationship between the x and the y. Okay, so the x variable is the dependent variable and the y variable is our dependent variable. Okay, so let's have an illustration. ABC Manufacturing Company has the following data for its electric consumption in the production area for the half of the year 2020. So ABC Company is a manufacturing company, and perhaps it has a problem regarding the electric consumption because maybe the cost for electricity is a mixed cost. It includes a variable component and also a fixed component. So here's the data for the half of the year 2020. So we have here for the months of January to June, the production level and the amount in US dollars. So when the production level is 1,000 units, the amount of electricity is 4,890. And when the production level in June is 750 units, the amount of electricity consumption is 4,700. So if you can see, the production level is increasing and decreasing. It varies, and so with the amount of electricity consumption. So we're going to use the graphical method or the scatter graph method to analyze the relationship between the production level and the amount in US dollars. So, but before that, we'll have first to identify which is the x variable and the y variable. Remember that the x variable is an independent variable and the y variable is the dependent variable. So here, our x variable would be the production level in units, no? Because they are not dependent on the amount of electricity. On the other hand, in contrast, the amount of electric consumption is dependent on the production level. Hence, this production level is the x variable and the amount of electricity consumption is our y variable. Okay, now let's plot this into a Cartesian coordinate plane. And we are going to use only the first quadrant because all of the figures are positive. So, step 1, draw a scatter graph and it will look like this. Okay, so we have here the x-axis is our independent variable, the levels of production or the production units. In our y-axis, on the other hand, is the amount of dollars spent on the electric consumption. Okay, so we have here the plotted coordinates of our x and y. The next step after drawing a scatter graph is to answer how do we describe the pattern of the graph. If you know it, it's actually going to the upper right. Hence, in mathematics, we can describe this as a direct proportional relationship because when the x is at 700 or more, below 800, the cost is just here. It's around 4.7, okay? But as the production level increases, the cost of the consumption, electric consumption, the amount rather, is also increasing. So therefore, there is a direct proportional or direct relationship between the production level and the amount of electric consumption. Okay? And we are going to draw a line, a straight line, out of this graph. So, in drawing a line, we will need to hit as many points as possible. Okay? We are going to hit, so in this line, we have 3, 1, 2, 3, 4. At least we hit 4 dots, okay, 4 ordinates. So your line can't be above or lower than that, because again we need to make a to we need to draw a relationship between these two variables. So therefore, if you notice, the line is going here. Okay, it's going up. So if you'll notice, the line here, okay, this line intercepts, or yeah, intersects at around, probably it's for 100. It's between at around 4,100. If you notice, the line here, the interception here, okay, it's between 4,000 and 4,200. It's probably in between. Okay, so that means at our y intercept, or when the x is 0, the y intercept is 4,100, right? It is not really as precise as the other two methods, but it would give us an idea of how the relationship between the two variables are working. So again, when the x is 0, the y intercept is also is 4,100. Okay? So this y-intercept is actually our fixed cost. And we are going to show that in our previous slide why it is our fixed cost. Okay? So, in computing a slope in our linear equation, no, basically we have this y is equal to mx plus b, but in computing slope, it will be the rise over the fall, or the y over the x. So, in computing the slope, the change in the y here, the change in the y over the change in the x, or the here, is the slope. Okay? Okay, so we will choose now which of the 2 points are hit by the line. So, here we have our first point, which is pretty much in the center of the line. And the ordinates for this point is 750 and 4,700. That means when the production level at 750, the amount or the cost is 4,700. Okay? And the other point that we will choose is this one. Okay? So that one, because between this one and this dot, okay, so it is mostly within the line, okay, unlike the other dot. So the ordinates for this dot, okay, so is 900 and 4,820. So when the x is 900 and 4,820 is our y. So when the production level is 900, the cost is 4,820. So we will use these two figures, these two ordinates, in computing our slope. So our y1 would be here, and the y2 would be here. Okay? And the x1 will be the 750, and the x2 will be the 900. And we're going to solve for the slope for these points. So we have here 4,820 minus 4,700 over 900 minus 750. And our slope will be 120 over 150. Therefore, the slope will be 0.80. Okay? That's the slope. And now we have already the slope, and of course, our y-intercept. So, let us recall our basic linear equation, the standard linear equation in mathematics. We will use the y-intercept equation to estimate costs. So our equation is y is equal to mx plus p, where the y is the total electricity cost of the month, and the m, the slope, is the electricity cost per unit of production or level. This is our slope and also our variable cost per unit. Okay? While the x here is the total level of production per month. So again, the Y is the total cost of electricity, and the M is the variable costs and per unit, and the X is the production level per month. Now, as I have said, the y-intercept in our graph is actually the B, the fixed cost. Okay? So, according to our graph drawing that I have just presented to you a while ago, the B is approximately at 4,100. Again, that is not precise amount, but that is just a visual you know visual estimation based on the graph we have just drawn. Okay? So we will use this equation in estimating our costs. So let us look at the table. Again, we have chosen 2 points. The 750, that's actually for the month of June. So 750 production level, and the amount in the cost of electricity is 4,700. And we have also another point that was for the month of March, which is having a production level of 900 units and the cost of 4,820. So we're going to use that. Let us check whether our solution is actually correct. Okay? We will use this June figures, or this June information. In June, the total cost was 4,700, and our slope, or the variable cost per unit, is 0.80, and production level is 750, and our y-intercept was 4,100. So 47 is equal to 600 plus 41, so approximately we got it correctly. However, as I have said, this scatter graph method is limited. It's not actually precise, 100% precise, because if you're going to apply this solution to other production level, we will get different answers. Okay? For instance, for the month of January, wherein the production level is 1,000 units and the cost is 4,890. So here, if you notice, okay, this following the same computation, 4,890 is our total cost. The variable cost per unit is 0.80, and the production level is 1,000 plus the fixed cost of 4,100. So we will get 4,890, and using these figures, the 0.8, the variable cost per unit, and the fixed cost, we will get 4,900. So it's actually not the same with the actual cost of 4,890. Hence, we can say that using a scatter graph, it has limitations. Number one, it only depends on the visual solution that we can see on the graph. Okay, and we cannot perfectly draw a line in the graph. In the graph, yeah. So this calls for another method which could somehow approximate, which is closer approximate to our fixed cost and variable costs. Okay, and that method is the high-low method. So high-low method does not necessarily need for a graphical solution. So when using this method, you're not going to draw a graph. You can draw a graph for more, accuracy, but it is not needed under the high-low method. It selects the use and uses the highest and lowest values of x, the production levels, to compute for the slope and the y-intercept. So again, our basis in the high-low method is the highest and the lowest x values, which in this case, the production level. So let's again take a look at this problem. The variable that we need to focus on is the value of x. So we will choose the highest and the lowest x values. So the lowest values of x, the highest rather value of x, is the 1,100. Okay, that's for the month of February, with a cost of 5,010 US dollars. And our lowest value is for the month of June, when the production level is at 750 and the amount of cost at 4,700. So we're going to use these figures in computing our slope and the y-intercept. Okay, we're not going to draw a graph. We'll just directly compute the slope. So our first step is to solve for the slope, and we're going to use the two pairs that we just identified in our previous slide. So in computing the slope, we have m is equal to the change in y and over the change of x. So y here is the cost, while the x is the production level. So m is equal to 5,010 minus 4,700 divided by 1,100 minus 750. These are the x values. So we will get m is equal to 310 divided by 350. And computing this, we will get 0.886. So this is actually much higher, higher than the slope that we computed using the scatter graph method, which is 0.80. So the slope here, the m, is actually the variable cost per unit of production level. And we are going to use this slope value in computing our y-intercept. So our next step is to solve for the y-intercept, or the b, which is our fixed cost, using the basic linear or the y-intercept equation, which is the y is equal to mx plus b. So the y is the total costs of electricity is equal to m. The m here is the slope, which we have just computed. That's 0.886. And the x is the production level. So the unknown value here, and the unknown amount here or figure, is the b, the value of b. So we're going to choose between the two ordinates that we have chosen, that we have selected in our previous discussion. So in this case, I'm gonna choose the 5,010 and the 1,100, the 5,010 and the 1,100 pair. So 510 is equal to 974 plus the b, and we're gonna solve for the b. So the b here is 510 minus 974.60. Therefore, the b, or the fixed cost, the y-intercept, is 4,035.40. In our solution under the scatter graph method, the b, the fixed cost, the y-intercept, was approximately around 4,100. But using this method, high-low method, our y-intercept, or the b, or the fixed cost, is only around 4,035.40. Okay, which is slightly lower than the previous computation. But again, it's actually it has its own limitations, because if in the linear graph, or if in the graphical solution we use the visual, the line in estimating the value of b, or the y-intercept, in this solution we only use 2 points, okay, 2 values of x and y. Therefore, it has also its own limitations because it ignored the other values given, okay? So, under the scatter graph method, our fixed cost is approximately at 4,100. But under the high-low method, our fixed cost is around 4,035.40. So, somehow close, but not really close. Okay? So, again, these two methods only use 2 points. In the graphical solution, in the scatter graph, it uses line to visually approximate the values of the y-intercept, and in the high-low method, it uses 2 points to solve for the slope and to solve for the y-intercept. Again, it has its own limitations. Okay, so the next question would be: is there a solution which is quite accurate, to the real solution, to the exact solution? Actually, there is. Okay, and that is the third method, the regression analysis, which we will discuss in our next video. Alright, so thank you so much for watching, and I hope you learned a lot from this video. See you in our next discussion, and bye!